We shall continue with the next part of round robin. Okay, I want to share with you the round robin tutorial. Okay, for the case where the quantum time is 2. Okay, the quantum time is 2. So the quantum time refers to the time slice, okay, given to each processes. Okay, for each process, what is the time slice or quantum time given? Okay, to ensure fairness. Okay, fairness. So what's the difference, okay, between the quantum time? So quantum, it can be in power of 2. So it can be q equals to 1, okay, 2, 4, 8, and so on. But usually we use quantum time equals to 1, okay, or 2. So in my case here, I want to share a tutorial on quantum equals to 2 using the same question from the Wilhelm-Stallings slide note. Okay, lecture note on uniprocessor scheduling. The same question here. Okay, like I explained, we will use the round robin rule here, alright, to get the finish time. Okay, to get the finish time in order to calculate the turnaround time. Okay, first we need to create a queue. Create a queue. Okay, create a queue. And using with the help of this rule, round robin rule. Okay, let us start. Okay, in this case, quantum equals to 2, meaning that once we execute the process, we will run 2 service time. Okay, run 2 process service time at a time. So first, at t equals to 0, process A arrives. So A enter queue. Okay, thus and the process before executed has remainder. There's no process before, so we simply execute the process. Okay, execute A. So remember to execute 2 service time because the quantum is 2. So remainder is 1. Okay, the remainder is 1. Okay, next, okay, we will check t time. Okay, meaning that here t equals to 0, 1, 2. So at t equals to 2, which process arrived? Okay, the next process arrived is B. B already arrived, so put it in Q. Put it in Q. Okay, next we check whether the previous process has remainder or not. Yes, it has 1, so put it in Q. Enter Q. And then execute next process in Q. Execute B. Okay, remember to execute 2 service time. Okay, B. Right, next check the t. Okay, time. So this is where t equals to 4. So t equals to 4, C arrives. Put C in Q and then check whether B has remaining or not. Okay, B has remaining 4. 6 minus 2, 4. So put it in Q. Alright, the next execute next process. We execute A. So A is only 1 because the remaining is just 1. Okay, so A has finished. So we check next t equals to 5 here. T equals to 5, any new process? No, there's no new process. Okay, A has any remainder or not? No remainder. So we execute the next process in Q. Okay, run C. So after run C, we check the t, next t, t equals to 6. So t equals to 6, D arrives. So D arrived, put D in Q. Pardon me, sorry. Before that, I almost forgot that C has 2. We have to run. Okay, run first. We run it first. Sorry. So after we run C. Remember, quantum is equals to 2. Okay, so C, C. Alright, so after execute C, again back to checking time. So T equals to 7. So at T equals to 7, D already arrived because D arrived at 6. So of course, at T equals to 7, D was already there. So put D in Q. Okay, so we already put D in Q. So the process that executed before, it has remainder C. Yeah, it has another 2. So put C in Q because it has remainder. Alright, next we run B. Okay, we run B. So B, it has 4. Okay, so we run 2 of it. B, B. Okay, remember, run B, B. So after execute, you check for the time. So this is T equals to 9. T equals to 9, the new process has already arrived. Okay, E. So put it in Q. Okay, so the previous process, B, does it has any remainder? B has another 2. Yes. So put it in Q. And then execute next process in Q. Run D. Okay, run D. D has 5, so we run 2 service time. D, D. Okay, so here this is T equals to 11. But actually, we don't have to check the T anymore, the time slot, because all the processes have already arrived. Okay, so no problem in terms of the arrival. Okay, we just check whether D has any remainder or not. Okay, D has 3 and put it in the queue. So next, execute C. Okay, C, C. Yeah, C because C has 2, so C, C. Okay, C, C. It has any more remainder? Okay, any more remainder? No more. C already finished. Okay, no more. Okay, next we run E. So E, it has 2. So just finish it. Okay, E, E. Okay, it has no remainder. Continue executing B. So B, okay, already finished. I will be finished because there's no more remaining time, remaining service time. So B, B. Okay, next we run D. Okay, D has 3, so D, D. Okay, the remainder is 1. Put it in Q because this is the last one, so we execute it and it will come. Okay, finish lah. Okay, it will finish. So basically, this is the round robin quantum equals to 2 scheduling. Okay, and you can see the pattern here. For each of the processes, we're given time slice 2. Okay, time slice 2. Okay, to continue getting the continue getting the finish time, I mean the turnaround time. Okay, so we will continue calculating. Okay, by list down again the processes and arrival time and service time. Again, arrival time is TA, service time is TS. So we list all the processes A, B, C, D, E. Okay, list it horizontally. Okay, the arrival time and the service time. 0, 2, 4, 6, 8. Service time is 3, 6, 4, 5, 2. Okay, 3, 6, 4, 5, 2. Okay, so we get the finish time by doing this. So finish time for A is 5. Finish time for B is 17. Finish time for C, 13. Finish time for D is 20. Finish time for E, 15. Okay, once you get the finish time, you can get the turnaround time by using this formula. Turnaround time equals to finish time minus arrival time. Okay, the turnaround time. So finish time minus arrival time. 5 minus 0, 5. 17 minus 2, 15. 13 minus 4, 9. 20 minus 6, 14. 15 minus 8, 7. Okay, so we already get the turnaround time. Then we can calculate the average turnaround time or mean turnaround time, okay, by summing up. Okay, 14 plus 7, and then divide by numbers of process, 5. Okay, then you will get the mean time of the average. Okay, this is average, average turnaround time. So basically this is the round robin quantum equals to uniprocessor scheduling.